In this video, we're going to talk about how to simplify square roots. So a radical is an expression that involves finding the root of something. A radical will have a radical symbol as shown here, and there'll be this number written on the outside, which is known as the index. The value that's under the radical symbol is known as the radicand. A radical with an index of 2 is written without the index. So if you don't see a number right here, that means it's an index of 2. And these types of radicals are known as square roots. Whenever we're working with square roots, we want to think about how to simplify them. And sometimes I'll refer to this as making the square root better. So for example, if we have a problem with the square root of 12, we want to simplify it and rewrite it as 2 times the square root of 3. In order to do this, we need to use something called the product property of square roots. This tells us that the square root of a product can be separated into the product of 2 square roots. So for example, if we have the square root of AB, that can be rewritten as the square root of A times the square root of B. So for the square root of 12, remember that 12 is 4 times 3. So we can rewrite this as the square root of 4 times the square root of 3. So let's use the product property now to simplify square roots. You'll start off by looking for the biggest perfect square that will evenly divide the radicand and write the radicand as a product. So for example, with the square root of 12, that's why I wrote it as 4 times 3. Because realize there are other factors of 12, right? So for example, I could have factored 12 as 2 and 6, but neither of those values are perfect squares. So that's why I wanted to write it as 4 times 3, because 4 is a perfect square. Then what you'll do is take the square root of that perfect square and then make it the coefficient of the radical. So for example, we take the square root of 4 and then we'll have 2, and that 2 becomes the coefficient of the square root of 3. So just in case you don't remember what square roots are available for you to use, I do have this chart of square roots in your study guides posted that you can use when you're working on these problems. So you can also simplify square roots of variable terms. So basically think about it. When we're taking the square root of something, we're undoing a square, right? So for example, if we have the square root of 4 squared, well, that square and that square root basically cancel each other out, and that's how we get 4. So it also works with expressions involving variables. For example, if I'm taking the square root of x to the 6th, okay, well, notice that that's x cubed squared, right? That works because the power property tells us that if we have a power to a power, we just multiply those exponents. So if we think about that, well, here I have x cubed squared and then I have a square root. So that squared and square root cancel each other out, and that's how this simplifies to x cubed. Okay, so the square root of x to the 6th is x cubed. So how do you know if a variable with an exponent is a perfect square? Well, if we're looking at square roots of variable terms with exponents, if the exponent is divisible by 2, okay, because remember that's the index of the root. So if it's the exponent like 6 is divisible by 2, then it's a perfect square. Okay, so that's how x to the 6th, when we took the square root, we got x cubed. If the exponent is not divisible by 2, then what you have to do is factor out the largest exponent that is divisible by 2. So for example, if we have x to the 11th, so the next biggest number that's divisible by 2 is going to be x to the 10th, right? Because 10 plus 1 is going to give me 11, right? Because the product property tells us that if you're multiplying 2 terms with the same base, you add the exponents. So that's why this x to 11, I can rewrite it as x to the 10th times x to the 1. Well, then if I use the product property to separate out these 2 square roots, I can have the square root of x to the 10th, which is going to be x to the 5th, right? Because this is now a perfect square. And then I just have the square root of x. So here's a problem-solving tip. Whenever you're taking the square root of a variable with an exponent, you can do so by taking half the exponent. So for example, the square root of x to the 24th, well, the new exponent is just going to be half of 24. So that's how I get x to the 12th. Even if you have multiple variables in your problem, you just take half of the exponents when you're taking the square root. So 36 divided by 2 is 18, 8 divided by 2 is 4, and then 10 divided by 2 is 5. Right? That's what we're doing back here too. Half of 6 is 3, and then when we took the square root of x to the 10th, that's how we got x to the 5th. So now let's put this together and find the square root of expressions. Because remember, expressions that we work with can have numerical portions and variables. So what we'll do is we'll use our strategy of looking at the coefficient and variables in the expression separately. So we'll find the square root of the coefficients by factoring out the largest perfect square that evenly divides the coefficient, then write the coefficient as a product and take the square root of the perfect square. For the variables, we'll just factor out the largest exponent of each variable that's divisible by 2. Then we'll write the variable terms as products and then take the square roots of the perfect square terms. Remember, when we're taking square roots, that means we're going to take half of the exponent. Then what we'll do is we'll reassemble all our terms and keep the terms under the radical together and the terms on the outside together. So let's see what that looks like. So here's how I go about solving these problems. So I just take this, okay, so I have the square root of 8x cubed y to the 4th, and I break it apart. So I'm looking at the square root of 8, the square root of x cubed, and the square root of y to the 4th, okay? I look at those three pieces separately. So when I look at the square root of 8, well, that's where I do these strategies when I work with coefficients, right? I just use my list of perfect squares and figure out what's the biggest perfect square that evenly divides 8. Well, that's going to be 4, right? So this can be rewritten as the square root of 4 times the square root of 2. Well, now I can take the square root of 4, because the square root of 4 is 2, so that's going to become 2 times the square root of 2. Okay, so now I leave that part alone. Now I just have some variable terms, so I'm going to use the strategies over here. To find the square root of variables, I'm going to look at my exponent. 3 is not divisible by 2, so I'm figuring out the next biggest number that is divisible by 2. Well, that's just going to be 2, right? So I can rewrite this as x squared times x to the 1, right? So remember, I used that product property because 2 plus 1 is 3. Well, now this x squared term, I can take the square root of it because that's just going to be half of the exponent. So that's just going to be x to the 1, or you can just write it as x. And the square root of x is just going to stay under the square root, okay? Now my next variable term is a y to the 4th. Well, the nice thing here is y to the 4th is divisible by 2, so I can just take half of the exponent. So that's just going to become a y squared term. So now all my terms that are in pieces right now, I'm going to take and I'm going to combine. I'm going to put everything on the outside, so I have 2x and y squared that are outside the square root, and then everything inside the square root, I just put under my square root sign. So I have 2 and I have x. My fully simplified answer. So now let's try this example. So we have the square root of 625, x to the 5th, y to the 9th. So I'm going to start by taking this apart. So I have the square root of 625, the square root of x to the 5th, and the square root of y to the 9th. Well, let's first simplify the square root of 625. Well, if I look at my chart, notice that 625 is a perfect square. The square root of 625 is 25, so I can just write this as 25. Now let's work on the variables. So here I have an exponent that's not divisible by 2. So the next number that's divisible by 2 is 4. So I can write this as the square root of x to the 4th times the square root of x to the 1, right? Because 4 plus 1 is 5. When I take the square root of x to the 4th, my exponent is going to be cut in half. So I have x squared and then the square root of x. Now let's look at y to the 9th. The next number that's divisible by 2 is going to be y to the 8th. And so that's going to be times y to the 1. Well, the square root of y to the 8th is going to be y to the 4th. And that's going to be times the square root of y. So now let's gather up all our terms. So everything on the outside is going to be 25. And then I have x squared and I have y to the 4th. Now let's put all my terms under the square roots together. So I have x and I have y. Okay, so that is going to be my fully simplified answer. So now let's try this example. So we have the square root of 75, x squared, y to the 8th, z to the 15th. So we have the square root of 75, the square root of x squared, square root of y to the 8th, and the square root of z to the 15th. The square root of 75, let's use our chart of square roots to help us out. The largest value that 75 is divisible by is 25. So we're going to use that square root of 25 to simplify this. So we have the square root of 25 times the square root of 3. The square root of 25 is 5, so we have 5 times the square root of 3. Now let's look at our x squared. Well, the nice thing here is that we have an exponent that's divisible by 2, so I'm just going to simplify that into x to the 1, which is just x. Y to the 8th is also divisible by 2, so I can just go ahead and turn that into y to the 4th, right? It's just going to cut my exponent in half. Z to the 15th is not divisible by 2, so I need to rewrite this as the next number that's divisible. So I have z to the 14th times the square root of z to the first. The square root of z to the 14th, I'm going to take half of that exponent, so I have z to the 7th, and then I have that square root of z, that's just going to stay like that. Now let's gather up everything we have on the outside. So I have 5, I have x, y to the 4th, and I have z to the 7th, and then everything under the square root. So I have 3, and I have z. So this is now my fully simplified answer. So now you can go ahead and pause the video and try doing this example on your own. So once again, I broke this into 3 pieces. So the square root of 90 became the square root of 9 times the square root of 10. So I have 3 square roots of 10. Square root of x to the 5th, well, I had to factor out an x to the 4th, so I have the square root of x to the 4th times the square root of x. Remember, when I take the square root of x to the 4th, I cut the exponent in half, so I get x squared square root of x. Y to the 4th, well, that's an even exponent, so I just take half of that exponent. That's how I got y squared. All my terms on the outside are 3x squared, y squared, and then I have the square root of 10x under my radical. So you can find the square root of an algebraic expression by looking at the coefficient and variables separately. Factor the largest perfect square possible from every term, and then take the square root of these terms to simplify.